Good morning, afternoon, good evening, wherever you are. This is the Wireless LAN Professionals Wi-Fi design class coming to you 100% free and 98% in English. We slip a few words in Spanish here and there, but this one is the exact same class that has been delivered to thousands of professionals worldwide. And now we're bringing it to you for free. Thank you for coming. Got people from Italy, from the US, from where else do we have people here? Just put it in the chat. We'll be bringing it up. Today is Sunday, July 26, 2026. We have session 358. I know. We have a group called Tesos and Wi-Fi. We gather every Friday or whenever there is an event or something happening or somebody needs help. From Nepal, we got people from Nepal and Mark from Texas. That's great. Thanks for coming. And we started teaching the Wireless LAN Professional Wi-Fi design class en Español for free. I don't know. We started back in February, I believe. And we've been taking that class that has been the Wi-Fi design class and just breaking it into sessions. And each session, we just, do an hour and a half, 2 hours, 2 hours and a half, 1 hour, whatever we have time to do. And the good thing is that we record them and upload them to the to this website called the Wi-Fi of Things, and all of the sessions are recorded there. So later, some of my friends said, like, hey, how come you're doing this in Spanish and not in English? I said, well, maybe we're going to do it in English. And we started. So there we are. If you go to the Wi-Fi-of-Things.com, if you're watching this video later, not today, live, this is how it works. If you want to participate in the live sessions, I created a form. Just put it here. Where's my forms? There. Let me share that link. Leave it here on the session too. And you can share this this link with other people, other friends that are new to Wi-Fi or people that want to learn about the technology. Then go ahead. Tell them about this class. This is the full class. This is not like, well, it's free. I'm just going to give you some and then you pay me, I'll give you more. No, it's free. It's that simple. So we decided to do that to help all of those that cannot afford these expensive classes nowadays and be able to get trained. So let me paste that. That's the form. There we go. That's the form that if you want to fill in, let me just get in. Man, why is this asking for all those passwords and stuff? Just, I believe is there's so many passwords for everything nowadays. Okay, let's see if that works. Yeah, let me see if I'm gonna have to, I think I shared the wrong one because I have to share the form, not this thing. So let me, that's probably not gonna let you open it, right? So give me 1 second. Yeah, I got all my windows covering everything. Let me just copy the form link. I apologize to you guys, but there is. Oh, I know where I have to go. I have to go to my. So Tom, you're in Croatia, huh? My son is traveling now in Europe, and he's in Split.
Ah, okay.
Yeah, he's in Split. He got there last night.
Still not too hot.
Uh-huh. Okay.
Next week is gonna be hell.
Croatia, I heard it's beautiful there. Let me see sheets. Where is forms? Man, I'm gonna have to save this link and keep it handy, huh? And the thing is, Google changed the colors and the icons and stuff. Ah, here we go. I couldn't find it. Wi-Fi design class. Ah, here we go. This is what I need to share with you guys. Free, published. So let me copy responder link. That's the one I need to send you. Okay. So now let me open the other All right, so that's not the link. This is the form. Let me share that with you guys. I put it in the chat, and if we open the chat, there we go. This is it. This is the form. So I pasted on the chat. That's going to be in the notes for this class, for this session. And then you just fill in your name and email, and I will send you the invites for this class live. If you cannot attend the class live, then you can just watch the video later, but you don't get to ask questions. You don't get to participate in the live session. So today is Sunday. I know you probably have things to do with your family. Let's get going. Thank you very much for coming from anywhere in the world you're visiting. So this is it. Let's talk about association. In previous session, now you know you can go watch the other videos later just to catch up to this point if you're just getting to it. But the association process covers the way devices in Wi-Fi join a network. When you connect to a network, they have to associate. Well, let's cover the association process. Devices will learn about the networks that are around them through a couple of ways. So let's break this into 4 steps, basically. The first one is going to be WLAN discovery. So the device will have to discover what Wi-Fi networks are around them. There are 2 ways. One is passive discovery or passive scanning. Passive scanning means that the device passively goes to a channel that we covered channels yesterday on the last session and listens for networks. Now, it listens to a frame coming from the access points called beacons. A beacon is a frame that goes out 10 times per second. So the access point is going to have radios, and those radios are going to be announcing the networks they offer. For instance, if I have a network called Peter, it's going to go in 10 times per second say, this is Peter's network. I can do this, I can do that. I am in the regulatory domain US. I am a 20 megahertz wide channel. I can do PSK for security. I can do CCMP for cipher. I can do for spatial streams. I can do everything. 10 times per second is going to make that announcement. If you have another network called guests, 10 times per second, the access point is going to send that announcement. Hi, I'm the guest network. I can do this, I can do that. I'm on channel 36. I can do 40, 80 megahertz wide channels. I can do 3 spatial streams. I'll tell you everything about myself, what type of security, regulatory domains, minimum basic rates, all that stuff is announced 10 times per second per radio. If the access point has 2 radios, and most APs do, then one radio in 2.4 is going to be making that announcement, sending a beacon 10 times per second. Hi, I'm the guest network. I'm in 2.4. I'm in channel 6. I can do 802.11b and G and N and AX, and I can do regulatory. 10 times per second is going to make that announcement. 10 times per second per radio. So in 5 gig, it's going to be also at the same time making that announcement 10 times per second. Hi, I'm the guest network. I am on 5 gigahertz. I'm on channel 36. I can do this. I can do, I'll tell you everything about myself. 10 times per second per radio per SSID. SSID is service set identifier, basically the name of the network. And if I have another network, let's say called IT, then 10 times per second is going to make an announcement that the IT network can do this, can do that, and it's going to be 10 times per second per radio per SSID. So the more SSIDs you have, the more beacons you're going to have in the air. The more air time is being consumed and the busier the network gets. Let me just give you an example. I went to a hospital once that I think was earlier this year or last year. I don't remember. Time's going so fast, but go and check the airtime utilization. So the airtime was 90% utilized. 90% of the time it was busy. And I'm like, wow, there must be something going on, like something really, really busy. And what happened was they had 14 networks being advertised per radio. There were 3 that were visible that you could see in your computer or your phone, your device. And then there were 11 hidden networks. Hidden, you probably have heard of hidden networks, is a network that also sends a beacon. And it goes something like this. Hi, I can do this, I can do that. I'm 20 megahertz wide channel, I'm channel 30. I'll tell you everything about myself, except the name of the network. So it's not seen, just the average Joe, the average person is not going to get their phone out and see those hidden networks. So they only see the visible ones. You can see the guest network and you can see the corporation network and you don't see anything else. So it kind of helps a little bit, but the overhead is still in the air. Beacon, 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 beacon. What happens is all of these frames, they have to go through all the contention process. I believe we already covered the contention process. Let me just review in here real quick. Make sure that we did cover it. Wi-Fi of things. Let me bring this guy down here. Let me move this guy to the side a little bit. And if we go to the WLANPros Wi-Fi design class, then we have channels. That's what we covered yesterday. DFS, AFC, CCC, all those acronyms. And then DB math, then modulations, and then we covered the contention process. That's in session 343. Contention process is that process that devices have to go through to gain access to a medium. So when you are sending beacons, those beacons also have to go through the contention process. For the access point to be able to send that beacon announcing the capabilities, it has to make sure that no other devices are sending waves at the same time. It has to make sure that there is no energy in the channel. It has to make sure that nav has counted down to 0. It has to get its interframe space. It has to go through a random backup process, pull a random number, count down to 0. And yes, it's management. The AP may say like, hey, I'm management, man. I got to send this beacon soon. So I'm going to pull a 0. Okay. You still, even though you have an advantage that you don't have to get a big number and count down to 0, you get 0 all the time for that one, I guess. I'm not exactly sure about that one, but I think that's how it works. Then it will go through the whole contention process and then send the beacon. But then if you have 14 networks in that radio, then the next beacon also has to wait for its turn to go out and make the announcement. So the network in that place in certain channels were at 90% utilization with 0 clients connected to a network. So the network, the airtime was just busy with beacon, 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 beacon. This network making announcements. 11 hidden networks. And I asked the guy, like, what are those 11 hidden networks for? Oh, well, there's one for voice and there's another one for, testing. So like, okay, that's 2. What are the other 9? And they couldn't tell me. It's like, I don't know. Because people that were there prior had created hidden networks for certain purposes and then they forgot to remove it. So keep that in mind because these beacons that go out from the access points, they will consume airtime. They basically will keep the airtime busy and you're not going to have time to do data transfers and stuff. Hey, Gabe, is that you, Gabe from Toronto, from Canada? What Gabe is that? Maybe.
Ironically enough, it's cutting out.
Oh, hey. How's it going? Yeah, it's cutting out. All right. And then we have Mike Heflin. Thanks for coming, Mike. Hey, none of you show your beautiful faces, man. Come on.
Hold on, hold on. I
Oh,
need
there
to-
we go.
Apparently my Wi-Fi, ironically enough, is not working.
I know that isn't that sometimes
This is
that's how it goes. All right. So beacon, 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 beacon. That is how clients will discover networks. Also, that's passively, okay? The device will passively listen, goes to a channel and listen for these beacons coming from all of the access points around them. Go channel per channel per channel and start getting the information about those networks. Then the clients can also discover networks actively. A client may send a probe request, which is a frame that goes from the client to the air, same as the beacon. The beacon goes from the access point to FFFFF. The destination address of a beacon is broadcast. It goes to the air, and then anybody hears it. Everybody gets it. Then the probe request is going to go from the client to FFFFF, saying, hey, I'm looking for the network called home, or the network called corporation, or the network called McDonald's, whatever. It puts a name and say like, hey, I'm looking for this network. If there is an access point offering that network, it may reply and say, oh, I am the home network. And then, it continues the rest of the process. If there are no known networks available, then the client may send a probe request that is direct, that it's open, a wildcard. So in the name of the SSID, and we'll look at these frames here in a little bit, but then the probe request is going to say, hey, I'm looking for a network like blank, any network here on channel 36. So any AP that hears me, I mean, if I was an access point, I'll say like, no less than a 1/10 of a second ago, I told you, I'm the IT network. I can do this, I can do that. But you know what? Access points, they don't get upset. They don't get angry. They don't have feelings. They will say like, oh, you're looking for a network? Hey, I can offer you the IT network. I can offer you the gas network. And he will send a frame called a probe response with a name, with a destination address, and like, hey, you're looking for a network? I can give you the IT network. And of course, this frame, the probe response, is not to broadcast. That is a unicast frame. It now has a destination MAC address, the MAC address of the client. The client sending the request to FFFF says, hey, I'm looking for a network. The AP says, hey, Gary, you're looking for a network? I give you the IT network, and it will tell you everything about the network. And I can do this, and I can do that, and I'm on this channel. I can do 4 special streams, and I'll tell you everything about myself. It's kind of like a beacon, very similar to a beacon. Difference is there are some fields that exist in the beacon, but they do not exist on the probe response. And one of the other big differences is that it is a unicast frame, not a broadcast frame like the beacon. This one has a destination MAC address. Then here's the other thing. Since it is a unicast, that probe response goes to a destination, it requires an ACK, an acknowledgement, to make sure that it was delivered. So it sends the probe response and it expects an ACK back, letting him know that, hey, I got the probe response. Thank you very much. I'm going to consider this in my decision making. So up to this point, that is the WLAN discovery process. The AP send beacon, 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 beacon 10 times per second per radio per SSID. The more networks you have in your organization, the more busy, the busier your airtime is going to be. So you want to keep that number to the lowest. I don't know, anybody here, what's the highest number of networks you have seen advertised in a place? I've seen 14. I don't know if there's anything higher than that.
I've seen 8.
8. Yeah, that's bad. What's the sweet number? Of course, now you see, Gabe, why we want to keep the network to just one. Just one network is good, but not always is feasible. Sometimes you have to have 2 networks or 3, Just try to keep it in that range. 3, maybe 4. That's pushing it, but just keep it at 3 or 2 or 1. You know, if you can do just one is good. Keep that number low. Let me move this thing to the side. And then if I click here where my Wi-Fi icon is, then that's the network I'm joined right now, the Cisco 9166i network. If I look at other networks, oh, not you. What I want to look at is all of these other networks. So all of these networks that I can see on my device, those are being discovered either by passive scanning, that this computer just goes to a channel and listens, or by actively sending probe requests out there on different channels. Access points also send probe requests. Access point may send a probe request because they want to build a database of the other access points around my area. So it is possible that an access point gets off channel, say like, hey, I'm on here on channel 36. I'm looking for a network, sends a probe request open, and then any other APs in the area will respond. So the AP is going to use this data to make decisions, how to, which channel to use, when to land on a channel, or if it's too busy and wants to recommend load balancing and kick people off the network and send them to another channel, then that's another way they can do it. Also, there's this tool called Wi-Fi Explorer Pro. Still have this open from last week. Let me scan the network here where I am.
I recognize those.
Yeah, huh? Bring good memories. You're home now?
Yeah, I am. Yeah.
Nice. So all of these are networks that have been discovered by this tool. In active mode Wi-Fi Explorer Pro, it goes and sends probe requests on all of the different channels, and whoever responds, then it starts building that database of networks around here. Of course, here we don't see very many networks. In a neighborhood and in my man cave, I don't have much going on, and a lot of APs that I use for testing, they're turned off right now. So this is what I hear. That's 2.4, that's 5 gig, and this is 6 gig. That doesn't seem right. I must have some 6 gig here somewhere. I do have 6 gig going on. Let's see. I'm scanning all. We'll see what's happening. But all of these are these are probe responses, and beacons, it also gets information from there. So for instance, if I look at this network called Cisco 9166, which it's in bold because that's where I am associated. If I click on this guy, the advanced details in here is going to show me, move this guy up a little bit. It's going to show me what's in that beacon or that probe response. It has the name of the network, the SSID, Service Set Identifier. That's the name of the network. The supported rates. This one is at 24 megabits per second. Traffic indication map. This one is actually in warehouses and in a lot of places, this comes in handy because when the access point receives data for you on the wire, and let's say Marco is sending data, and of course I cannot send data to Rafael because I am letting Marco send his waves, then I queue that data, and then in the next beacon I send in the traffic indication map, I'm going to include the association identifier of those that I have data queued for. So, and then on the next beacon, I'm going to say, hi, I'm the Cisco 9166 network. I have 24 megabits per second, and I have data for Tom, and I have data for Ashik. And then you guys know, like, oh, you have data for me, and then you come and get your data. So that's another field that is in the beacon. Also, country. This has a regulatory domain US. Why is that important? Because as we saw in some of the first classes, the regulatory domains will tell you what power levels you can use, what channels you can use. And then by setting up the regulatory domain, the access point knows like, oh, I'm in the US, then I can do 30 dBm on this channel. I can do only 24 dBm on these other channels, and so on and so forth. So the country information is extremely critical. And I've been to places like I did a warehouse in the Dominican Republic, and they had access points with regulatory domain Brazil. Like, why? And then that could be source of a problem. I had an access point. Actually, I had an access point with regulatory domain Brazil here. I still have it because back when they opened the 6 gigahertz band, I got an access point for my friends in Aruba, Mexico. So I got an Aruba 635 access point, and I had it here, and I couldn't join that device with a couple of phones I bought at Best Buy. So I called my friend Marco, not you, Marco, another Marco that lives nearby, and he was testing 6 gigahertz with Ubiquiti, and he had APs and phones, and he was just showing that he was working. So like, I have these phones and I'm trying to join 6 gig, but I can't. Can you come to the man cave? And he came down and brought his stuff, and he fired it up, and then he couldn't see his own stuff. His stuff was working fine at home, but brought it to the man cave and it stopped working. Like, the hell, what's going on? I cannot connect to my 6 gigahertz stuff. Well, happened that the access point that he had regulatory domain US. When they detected one access point, my access point, saying, hey, Brazil, hey, I'm Brazil. They said, oh, Brazil, like, I'm in the wrong place. I cannot operate in this regulatory domain. So it shut down the 6 gig radius. So it's very important to know that the country, that the regulatory domain that your access points are may have certain limitations, okay? And they may not work depending if you buy something in Canada and you take it to Nepal, then maybe it's not going to work, or certain channels are not going to be available. Or if you bring an access point from another place and try to plug it in, it may not have everything that it's supposed to. And then it may detect the local regulatory domains from other beacons in the air and say like, oh, I'm not supposed to be in this regulatory domain. And boom, shut certain things down. Questions or comments up to this point? In the beacon, there is also another information element called BSS load, basic service set load. In some IPs, they call it QBSS load. But what this has is how busy is the channel. The channel utilization that we see in here, you just see where it is, channel utilization. Right here, see, so it shows channel utilization. It says this channel, which channel? Well, I'm on channel 36, I'm on an 80 megahertz wide channel. Then it says this channel is 11% utilized. Oh, it's 23% utilized now. So what it does is that it reports how many stations you have connected and what is the utilization of the channel, okay? This is reported by the access point. This is if the access point reports that, because this is one of those information elements that not every vendor advertises.
Does that include interference or?
What was that?
Does that include interference or probably not? Depends on the AP.
Depends on the AP. They will report this, but this is mostly, and it can be both. Let me actually get my Spectrum. I have a generator in here. Let me just generate some raw RF. And then we'll get that answer. But it will, and every vendor is going to report that. Where is, it's probably on this side. Okay. So if, let me get this guy out. Some vendors will not report any channel utilization at all. Let me turn this guy on. And hey, let's play. Channel 36. Let's generate some raw RF. 17 single channel. Let's switch to 5 gig single mode on channel 36. Just raw. RF. And let's also get a spectrum analyzer here. See, Gabe, I have not even unpacked.
Me neither. I still have a full suitcase.
Okay, let's plug this spectrum analyzer in here.
So Ferney, this is just for 2.4 and 5, right? 6 gigahertz is a little bit different discovery.
Oh, it's kind of like the same, but there are other ways in 6 gig that it will discover networks. Yes, it will also send probes, but it mostly gets it. We're gonna see it down here from the reduced neighbor report. Let's see, because this guy is. Yeah, we'll look at another access point that has a reduced neighbor report. Yes. So let me see if I can plug this guy in. Look at the spectrum. Connect and start. It's gonna work. Oh, this guy's not plugged in. That explains it. All right, let's see if this works now. Connect. I need a long cable. Okay, man, I haven't unpacked and I have all my stuff spread out. I have to get ready for class. Again, I'm going to Reno, Nevada in 2 days. A private class in there. Okay, let's see if this guy helps. An extension cable that I got lots of, and now I cannot find any. See? Okay, let's do this. Let me just unplug a couple of things in here. Make sure that the microphone is not unplugged. Here we go. Okay, let's sacrifice the camera now. There we go. I found it here. Let's put this guy back in. And this one in here. And that one in there. Let's see if now it works. And let's put it in 5 gig. Here we go. Okay. Let's turn my camera back on. All right. So in channel 36, this guy's reporting 11% channel utilization. I'm going to generate raw RF with this device. Oh, turn this on.
Just generating noise or something?
channel 36. And well, this only went up 14%.
Yeah,
Let's see.
I think the noise you just generated also cut you off.
Yeah, we lost you there for a second.
Yeah.
Yeah, that happens. So we can do this. Let me just generate it. Hang on. Let me not just select this guy, but all of these guys. So if we look at channel utilization, notice that some APs reported, some others don't. So that AP 45 is a missed AP that I have over here, and that is on channel 149. So, and that's reporting 2% channel utilization. Let's generate the signals then in there. Just go back here. And let's do it again, but this time we're gonna do it in channel 149. Let's see if that guy reports a change. Okay, next, let's do it at 17 dBm. Now this will not affect us. And now if I go to this guy, now all the activity should be now on channel 149. See, I'm generating on channel 149. And let's see, this guy's gonna report any different. Let's probably stop this guy and refresh. And bring our channel utilization chart in here. And that's the guy on channel 149. Where did it go? Huh, it is possible that it moved. Here, where's my AP? 45. Sometimes by generating the energy, it just move to a different channel.
Right. Because that's the thing is you can destroy a channel completely and still it report channel utilization of 0 one at a time.
Absolutely. Yeah, and the thing is when you're generating noise, then depending on how the device is measuring, if it's just using like either beacons or attempts to send data, it's just going to report like there's no traffic in the air, and then it may just not report anything, or just move to a different channel. So let's sort this out. I think that guy even got out of channel 149 and went somewhere else. Let me stop this guy. And now, here, let me show you the other way that we can do this to show the change the channel utilization. I am connected on, see, I'm on 2.4 now. You lost me when there was noise on channel 36, the AP, the device, the computer said, oh, this channel is busy, there is interference. I'm gonna find me something better. And it moved to home 2.4, it moved to a different channel. So now let me connect back to this guy. Hello, hello.
Hello, you bet.
Okay, I'm back. So yes, when I move from 2.4 to 5 gig, of course, I disconnected from the radio and connected back. Am I back? Because this thing shows that I'm still connecting.
Oh, you're here.
Yes, you're back.
Okay, now I'm back. So yes, I disconnected from 2.4, connected to this guy. I'm on channel 36. See, this guy is still there. There's the AP 45, but it was gone for a little bit. You lost me for a moment because I was moving from one to another. But watch this. Now on channel 36, where I am connected on this guy, channel 36, 11% channel utilization. Let me start something I do not recommend. If I go, let's say, to fast.com, now I'm generating traffic in the air. This guy pretty soon, just make sure that we refresh this. Come on. Refresh, refresh, refresh. It may take a while to catch up, but then the channel utilization when you're doing a speed test is going to go to 90% channel utilization. This guy's not reporting correctly. Let's do this. Let me join this device because I know Ruckus does report this very well. Let me make sure I am connected to the Home 5 network, which is this guy, and that is on channel 52. So what's channel 52 right now? It's at 18% channel utilization. I'm going to start a speed test. Oh, my battery's running low too. I'm going to start a speed test in here. And make sure that I am connected on this guy. And it went to 80% channel utilization just by doing a speed test on my phone on that channel. This is why I'm against running speed tests and doing internet throughput testing, because every time somebody runs this, the channel is busy. It gets so busy because this guy's trying to push big packets to get a big number on the speed test results. So that field, let's just go back to where we were, is looking at the information elements of this guy. Just get this guy here. So we were looking at the country, and then the basic service set load, like channel utilization, will report how many devices you have and what's the percentage of utilization. Power constraint, the TCP, this is 802.11h, the transmit power. If we look at the transmit power field in here, it says it's at 23 dBMs. So all that information we get from the access points, if it's at 9 dBm or 16 dBm, then it's reported in here. The HT capabilities, HT is 802.11n. So it's going to give you all the capabilities for N. If you have N devices, then if they only understand N, then here's what they can do. And it's going to give you power constraints and aggregated MAC protocol data unit parameters. And it's going to give you beamforming information. All that stuff is in here. Robust security network information element. If you have a password, if you are using 802.1x, if you're using OWE or SAE, we'll see those in future sessions. But here it shows that network is your pre-shared key, and it's going to give you the authentication and key management suite that you're using. If you are using CCNP 128 or 192 or 384, one of the stronger ciphers out there for encryption, all that information is announced in the beacon and in the probe responses. Let me probably stop this guy and stop you too. Go. Let's turn this guy off. Clears up that channel. And let me close this application. There we go. So that my CPU is not utilized. It will have the information about the security. It will have information about 802.11ac, short-guard enable, 80 megahertz wide for spatial streams. It will tell you information specific about the vendor. If you're doing Passpoint, that's going to be also specified down here. Any Cisco compatible extensions that are included, it will also be announced in here. The management frame protection, all that stuff is listed and included in the beacon. As you can see, the beacons have a wealth of information. In the beacons, we discover not only the name of the networks, because see, if you come over here and you see this list, it just shows you like what networks are available near you, wherever you are. But it doesn't tell you much more than that. When you have an application like this, it will help you get all of the data from those beacons and show it to you. When you're troubleshooting at a site, when you are designing, when you're doing things in enterprise, the beacon has a wealth of information. The beacon is so important that every vendor out there, Ekahau, Cedos, Hamina, Wavely 5, Netally, All of those get, when you're doing a survey, they get nothing but beacons. That's all they get, the beacons. And then, of course, I receive those beacons, and depending on how strong is the signal when I get it, these guys are NEC 26, because it's right here, right behind me. So there are other guys, if I come here, there are other guys that I can hear at NEC 70. That's far away. NEC 81, yeah, very far away from here. Others are NEC 30, NEC 40. So the signal strength is what I can hear that beacon at, and then I can start looking at the SSIDs. That guy, for instance, they don't advertise channel utilization. So let me collapse all this stuff in here. And then it has the SSID, supported data rates. Notice that it's like 1, 2, 5, 5, and 11. That's all B rates. That should be changed to, I don't know, 12 at the minimum. And then that's for 802.11b. This is direct sequence spread spectrum parameters. And then the country TCP report, ERP, that's for 802.11g stuff. This is for N capabilities, security. It's also a network with a PSK, and it has CCNP, and has all the information that that vendor advertises. It does not have the QBSS load field. It, of course, will have similar fields, but there are a lot of vendor-specific stuff that gets listed in there. So every radio of every AP out there is going to be sending these beacons announcing all of the capabilities of the network.
Those RFC standards for the header IDs, like who defines them?
The what?
The headers themselves and the beacons, like especially the vendor ones.
Well, there are some that in the standard, of course, they say, you know, what's the format and what are the fields that are required, but there are many optional, and the vendor specific ones, they just open it for, like the one that we were looking at, the Cisco. Then Cisco make their own announcements in there using CCX. But if in here you're announcing certain capabilities and the client does not understand CCX, all it's going to hear is like blah, 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 blah. Yeah. And it's not going to make any sense.
Yeah, okay.
Wi-Fi Alliance, they may send their own. Broadcom, Intel, all of the manufacturers, they may use some vendor-specific information elements to include additional data to help their clients or to help other APs in the area communicate. So that's so open. And yes, there are some common ones, like, you know, the SSID, supported rates, the team, country, BSS load is optional too. In some vendors, you can enable or disable certain fields. For instance, the AP name. See, notice that, for instance, this guy, I don't know what the AP name is. They don't advertise it. But this guy, the MIST, where is my MIST guy? Well, if I look for this network called Keith, see, in here, there is the access point name, which, as you could see last week, was extremely useful to have the AP name on the beacon, because in a place where you have like 200 access points and you're trying to look at one specifically, having the AP name and having a good naming convention makes a difference, huh? Because now in here, see, there's a field called vendor specific AP name. And then it says which is the name of that AP, so you can identify it. Let me share this guy again. Put it over here. And so that's the WLAN discovery process. Beacons, probe requests, and probe responses. Questions or comments up to this point? All right. Then after the client, because the client now goes through, either passively scans and goes to a channel and listens for beacon, or actively sends a probe request in different channels, goes to channel 36, sends a probe request. All of those responses it saves, goes to channel 40, sends a probe request, receives probe responses, and all of those networks and names that it gets from those beacons, it saves them and builds that database. And now the client has to decide which one of these networks am I going to join. Am I going to give priority to a network I have joined before? Am I going to give priority to a network that is secure? Or am I going to give priority to a network that is open? Or how am I going to make the decision? Here's where the green diamond comes into play. The green diamond, that's not in the standard. It's just a term that Mr. Parsons and we have used in training for years to try to explain this decision matrix that each device has. The green diamond is the process in which the client now has to decide, how am I going to choose which access point to join? So we're going to go through each one of these steps in detail. I mean, we've covered enough detail. We're just going to go through some of them faster. But then the next step is the open system authentication. Once the client decides which radio to join, it's going to send an authentication frame. It goes from the client to the AP. Now, this is open system authentication. It is there, but it has nothing to do with authentication. What? I know, the word itself says authentication. What comes to mind when you hear the word authentication? Well, you know, password, credentials, who are you? Like, no. This is open. Basically, the client tells the radio, like, I like you. And the access point immediately after sends an authentication frame saying, like, okay, you're in. There's no passwords, no credentials, no challenges, nothing gets exchanged other than, I like you, okay. And then you're in, you're authenticated. This authentication has nothing to do with passwords. That's the open system authentication. It changes depending on the type of authentication that you're using. If you have a PSK, a password, then that will go in here. See down here, it says authentication. So let's go through this open system authentication. The client says, I like you. And the AP like, okay, you're in. Now you're authenticated. Now the client sends an association request, okay? Association request. The association request frame is extremely important because in this frame, we learn the capabilities of the client. See, so far, you have seen the capabilities of the AP. In the beacon and the probe responses, it sends everything. I can do this, I can do that, I can do this many special streams, I can do 802.11n, I can do 802.11c. We just saw that looking at those frames with Wi-Fi Explorer Pro, okay? But we haven't learned about the capabilities of the client. And that's one of the biggest things when you're troubleshooting clients out there. If you're at a warehouse and they have barcode scanners, and then you want to know the capabilities of that, yeah, they may give you a model and then you look it up on Google and then it comes up with a spec sheet. They say like, yeah, I can do 5 gig. Okay, that's it. Doesn't tell you much. If you capture the association request frame, this is like the reverse of beacon. The client is going to tell the AP, okay, I discovered you. I told you I like you and sent my authentication frame. You accepted me and authenticated me. Now, I want to associate with you, and here is what I can do. I, the client, can do 2 special streams. I, the client, can do 21 dBms of maximum transmit power. I cannot go any higher than that. I can do, and I will tell you everything about myself. Now, this is the client listing all of the capabilities of the client. So at the AP is like, oh, yeah. So when I talk to you, you can only do this, you can only do space stream, you can do N, you can do, and then I know the details about you. Now, when Hando connects, then he tells me everything about himself. So I keep that on my database knowing that, oh, yeah, when I talk to Hando, this is what the parameters I'm going to use because here are his capabilities. And same thing for Saul, and same thing for Tom, and same thing for Brennan, Sebastian, and everybody. When you associate in that association request frame, the client is letting know the AP its capabilities, spatial streams, transmit power, all that stuff is going to be in the association request frame. Questions about the association request frame? Once the client, huh?
I'm good.
You're cutting off.
Oh, yeah. It might be my Wi-Fi. I'm good.
Okay, perfect. So the AP receives that, and if everything is good, it sends an association response frame. Basically saying, oh, okay, you chose me, I accepted you, now you're telling me everything you can do, then here's my association response. You are associated, and now you have an association identifier. From now on, I'm not going to call you Ned. I'm not going to call you MAC address ABCD. You are association identifier 17. Remember that team field which says, you know, I have data for you? It's not going to say, I have data for you, Ned. It's going to say, I have data for AID, association identifier 17. Ned, you know, your association identifier 17. Then, you know, it's got data for you. Okay. Access points are not going to have a CAM table. They're not going to have a MAC address table. They're going to have an association table. So that is how other devices will find you in the network. They are looking for a MAC address, and then the switches get that MAC address. Say, oh, yeah, the access point has this MAC address on his CAM table on the Ethernet side. I'm going to send it there. The access point receives that.
They do. I mean, they have their bridge, right? Their switch, really.
Yeah. They work like a bridge, yes.
Yeah.
And then they're going to they have their internal MAC addresses, and they have that match with the association identifiers. Say, oh, MAC address ABCD is association identifier 17. Then in the beacon, when it's going to send the team saying, hey, I have data for this MAC address, it doesn't send the MAC address. It's too big, takes too long. So to reduce, to be more efficient, so like, I have information for AID 17. That's it. So it's simpler.
Right.
Okay.
Yeah, most access points run Linux, right? And
yeah. Oh, absolutely. Yes. So and we talk, and you see documentation, they say they have the association table. Okay. That's what we refer to as.
Right.
Yes, that AID translates to a MAC address, and that MAC address somewhere else translates to an IP address, and then that's how the whole thing goes. And remember, Wi-Fi only works at layer 1 and layer 2. That's it.
I guess it depends if you're running proxy ARP or not, but yeah. Okay, I get it.
Yes, absolutely. All right. Now that the client is associated and has an association identifier, the client is connected to the AP. Association is to wireless what the link light is to the wire. You know, you have a wire, you plug one end to a switch, and then you plug the other end to a computer, and when you get blinky, that means layer 1 is working. You're connected. Oh, but I'm not getting an IP address. Then you have an IP address problem, but layer 1, if you get a link light, it's working. If you get an association identifier, don't tell me Wi-Fi is not working. Wi-Fi is working. I already got beacons. I sent probe requests. I got probe responses. I sent authentication frame. I receive an authentication frame back. I send an association request. The access point review everything and sends me an association response and get an association identifier. Wi-Fi is working, but I'm not getting an IP address. Then you have an IP address problem. Does this sound familiar?
Yes.
Yes, it does.
Okay. Once you get an association identifier, you already exchange all those frames with the access point. Wi-Fi is working. Okay. Very simple. Now is when the authentication methods come into play. If you have PSK, then there's going to be a process where maybe we'll have time later in another session and just go through PSK and explain it, because it has a password. And then you type that password. That it's just, you know, nobody comes to your house saying, hey, Gabe, do you have the PSK for your 802.11 network? Nobody talks like that. They're going to say, hey, what's the password for the Wi-Fi? You know, then you just give them a password. They put that password in, and then there's going to be a 4-way handshake where encryption keys are going to get generated so that you encrypt all the traffic in the air. And then after that, there's going to be the DHCP process. Okay. There's going to be a DHCP process, the DORA process, where you get an IP address. At the end of this session, we're going to review an association process from the probe request all the way to getting an IP address of a client. We're going to do that here, analyze that. We're 1 hour into this class. Of course, it's 7 in the morning. We started at 6 in the morning. For those of us here in the mountain region in the US, You guys that come from other parts of the world, thank you very much. Must be afternoon for you or noon or later today, but hey, anyway, it's Sunday. I know. Thank you very much for taking time to come and make me company, or else I'll be very lonely.
Don't cry.
So let's continue. Let's go over the WLAN discovery process. We already went through this. There is passive scanning, okay, and there is active scanning. Passive scanning is when the access point sends beacon, 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 beacon. It goes in the air to FFFFF 10 times per second per radio per SSID. 10 times per second per radio per SSID. The more networks you have, the busier the network, the airtime gets. That's bad. That's why when somebody comes and say, hey, I need you to create a network for marketing and another one for sales. Like, why? Well, you know, the person that sold the APs, they said they have 16 networks that we can have. So I'm going to create one also for the manager and one for the CEO and one for, like, how many networks do we have left? Like, no. It doesn't work that way. The less networks that you have, the better your network is going to perform. Because if you have way too many of them, they're just going to be beacon, just making all these announcements in the air. It increases airtime utilization, it increases channel utilization, and it decreases the amount of free time that you have to send data. So keep the number of networks to the lowest, okay? And yes, you may watch this video and say, oh man, I maybe have too many networks. Yeah, start reviewing that. Go through and make sure that any unnecessary networks, remove them, okay? Don't hide them. Oh, I'm going to hide this one. It still keeps sending beacon, 10 times per second per radio per SSID. So keep that number to the lowest. Clients can also discover networks actively by sending a probe request to the air, and then the access points that hear that device in that channel will send them probe responses. Here is the other reason why having too many networks is a bad idea. Not only you're sending beacon 10 times per second per radio per SSID, every time a client comes and says, hey, I'm looking for a network, then the access point is going to say, I'll send you probe response. I am the guest network. And then wait for his turn and say, oh, and I am the IT network. Oh, and I am the corporation network. It's going to send you a probe response for every single network you have. It's not like it sends you one probe response like, oh, yes, sure, Ned. I can do IT, I can do guest, I can do management, I can do marketing, I can do sales. No. It sends one probe response per network. So every time that phone that is in your pocket or in your table that you're not using because you're on the computer, every time that phone sends a probe request on channel 36, any AP on channel 36 is going to send probe response per SSID. Woohoo! That's another reason why having too many SSIDs is a bad idea. Questions or comments up to this point? You guys even there?
Yeah, I'm here.
Yes, we
Okay.
are.
Yeah, as
All
far
right.
as like the beacons, like the channelization, like how bad is it really? Like, is
Bad.
it
Bad.
okay? No, I know, but
Actually,
like as far as like
there,
data rate, like let's say,
Overhead.
yeah, like what's the
there,
overhead really?
there is a document. Let's see. I have everything on a. That's gonna be what's his name? Andrew Vonage.
I realize it's bad. It's just like I wonder what the overhead really is.
Yeah. There's a spreadsheet. I have it over here. Let me remember the name. Andrew Vonage. What's his? Oh man, my mind's going blank. Andrew Vonage has got the SSID overhead calculator. Here we go. Overhead
I guess we can
calculator.
Google.
It's right here. It's right there. And I'm going to share it with you right now. I'm going to put it in the chat if I can find it. Here we go. This is it. Revolution Wi-Fi. That's what I'm trying to do. Ooh, Sebastian,
pretty bad.
MPSK. MPSK, we'll talk about MPSK here in a second. Okay, let's see. And here's also where the minimum basic rate has a very good value. If I'm using B, 802.11b, okay, if I have one SSID and one AP on a channel, let's say channel 1 is announcing it, then I'm using 3.2% of airtime just sending beacons. If I have 2 SSIDs, 6, if I have 3, if I have 4, if I have 6 SSIDs, if I have, like this guy had 14, I mean, it only goes to 10. But if I have 10 SSIDs that I'm announcing, then I'm using 32% of airtime on just beacons.
So how the hell did it work with 200 APs, you know, from an event last week?
Yep. Well, if they are on the same channel, that's why we try to reduce every little bit of airtime we can get. We get having more SSIDs. If I have 2 SSIDs, okay, watch this. And let's say there are 10 radios in the same channel that hear each other. And we had, 10, 9, 12 that saw each other. Then 64% of airtime is going to be less. Now, this is at these data rates. If I change this data rate to be, let's say, 24 megabits per second.
Right, which was what we were using, I believe, right?
Yes.
Right.
So that's why we wanted that high, because with one SSID, 10 APs, we're only using just 1%. Oh, well, 2% of airtime just on beacons. Okay, that's not data. That's just, so let me share this document. Let me save it here on my save as, and let's put it on the downloads so that I know where it is. And then I'm going to place it in the chat for you.
Thanks.
Dropbox, your computer, downloads, Wi-Fi, SSID, overhead calculator. It's just an Excel document that Andrew Vonage, bless his heart, he created this many years ago, and it still stands true. That hasn't changed, okay? Make sure you guys can open it and keep that handy. Okay, now you know. When somebody comes like, hey, can you create another network? Like, no, why? And they may have reasons why. Well, we want them to be on their own network. Well, that's a thing. So the passive scanning in the beacon, as we already saw, the access point is announcing its SSID and network. The RSSI, you receive that as the SNR, which is, I don't know, a value that I don't trust very much, the type of authentication, the channel utilization, encryption methods, the MCS rates, supported rates, what amendments, if it can do 802.11k or R and V for roaming, all of that stuff is in the beacon. Then that beacon, as we saw, is going to have all of that information in different information elements. Some vendors may have more things than others. It's not like every beacon is made the same. It has some structure, and then it has a lot of optional and additional vendor-specific fields that vendors can use that for announcing specific things. And also, we include all of the capabilities of that radio, that AP in that location. Okay, that's what's included in the beacon. The WLAN discovery is active. The active scanning is a probe request. The client sends the probe request to the air. Then the APs that hear him on that channel will send probe responses. This is kind of like what a probe request is going to look like. We're going to look at one of these later at the end of this session. Then the access point is going to send a probe response. Notice that it's pretty much like the beacon, but the destination address is the address of the Apple device or the client. Notice that these beacons, the destination address is FFFFF. It has no destination. It goes to the air. Everybody gets it. Same thing with a probe request. Notice that the destination address is FFFFF. It just goes to the air. For a probe response, now it's unicast. because it has a destination address. It's specific for you, babe. It's going to send them all of that information, but that's for that client. Then now the authentication process comes, the open system authentication, no passwords, no credentials get exchanged here. And then here's where the client sends the authentication, the AP responds with an authentication frame. Some people and some documents call this the authentication request and authentication response. It is not officially called an authentication request. It's not a request. We call it request to highlight that it goes, it's a request from the client to the AP. I like you, I want to authenticate with you. And the authentication response has to be in the positive. It's like, okay, you chose me, I take you, and you're authenticated. And then it is a small frame that goes from the client to the AP, and the AP sends the authentication to the client. Look, it's a small, 70 bytes. You're like, okay, chose me. You're successfully authenticated. Open system, you're in, man. Then comes the association process. This is the frame that when the client sends the association request to the AP with all of the capabilities of the client, special strings, regulatory domains, minimum basic rates, all that stuff, then the access point reviews all that and sends an association response. The association request, of course, has a destination address going to the radio I chose. And then the association response is going from the AP to the client, and it has the information, including the association identifier. You're the first client associated, you are AID 01. That's simple. Then it comes to authentication. This is the authentication that includes passwords, credentials, usernames, all that stuff. If it's open, then there is no authentication. There's no passwords. There's no nothing. You just in, and then you move on to getting IP addresses, DHCP. If you have a PSK, if you have a pre-shared key, then that's what gets it changed. The AP is going to send a challenge like, hey, I got a password. Then this guy's going to be like, oh, I got a password too. And then it compares like, oh, our passwords match. And then it sends all the encryption keys, and the client will place those keys, and that's what they're going to use for encryption. We'll probably have a session on just PSK authentication and see how these encryption keys are created, okay? This is very important. And why this is crackable. This is not safe. This is not efficient, because if we have to change the password, like let's say you have an event with 9,000 people, and then you have a password, and then you have PSK, and something happens, gets compromised, and you have to change it, then you have to touch all of those devices and put the new password in them. That doesn't sound like fun. At the school district where I used to work, we had 27,000 devices with PSK. I know, bad. That was many years ago. And then we're like, yeah, let's change that. Like, yeah, that means we're going to have to touch all 27,000 devices that we have in the school district. 50 buildings in 5 cities. Yeah, that's a big project. So PSK is not very convenient. I mean, it's easy, but at the enterprise level, not very convenient. It's easy to crack. So not recommended. That's what they call the 4-way handshake. And then if you have a radio server, if you have that 1X, that's a more complex type of authentication. You have the access point, that is the authenticator. Then you have a client that is the supplicant, and then you're going to have an authentication server with either a database or internally radio server, remote access dial-in system, or you're going to have an LDAP or Active Directory, or you're going to have a database somewhere else. Then this server has to act with that server, and then the controller has to work with all of them. Then it's more complex. It's more secure, but it takes more time. It takes more expertise to authenticate users on the network. It's not just an exchange between the client and the AP. There's going to be another exchange between the AP and the authentication server. So yes, in the troubleshooting class, Zaur, if you can join us in New York when we have a class in a few weeks, we will go over this process, and we will be capturing data on the air and capturing data on the cable to analyze this type of things. Then the authentication, after you go through the .1x exchange, and then you generate the pairwise master keys, then you go through a four-way handshake, just as you did with PSK. You're going to use that PMK that was generated to generate the encryption keys for that session. And then after all of that happens, then you go through the DHCP process, the DORA process. Questions, comments, insults?
Does PSK sit inside TLS? I never thought about it that way.
So PSK,
Yeah.
it is not. It is not until it's one.
Oh, I mean, sorry, if you use 802.1x and it was using TLS, does it then, like, what, inside the tunnel, right? So once you establish.
Yeah. It's going to be that's why this method is more secure. Yes, it's going to start using, of course, radios has its fallacies. Nowadays, the recommendation is using RADSEC, which is radios over TLS. We will see in the troubleshooting class that this radio stuff sends things in clear text. Then by putting that on a tunnel, then everything is going to be encrypted. But PSK, not secure. Well, it is somewhat secure. It's easy to deploy, but it doesn't scale very well. And it's not safe. It's not secure, basically, because it can be cracked. MPSK, well, because here's what happens. You go through a process, and to generate the encryption keys, you're going to use the password, the length of the password, the SSID. Oh, let me go back. Delete. When you're having PSK, what it does is it uses the SSID, the length of the SSID, and the password. And it scrambles that like 4,096 times. There's a pseudo random process in which it generates a hash, a 256-bit hash, okay? Then that guy is going to be used to generate, that's going to be like the seed to generate the encryption keys. Not only, so that's one portion of it. The equation to get those encryption keys includes so the PMK is basically the PSK. And the PSK is not the password. The PSK is that hash that comes from the SSID, the length of the SSID, the password, and then those three elements get hashed in an algorithmic function, and then it generates that hash. That is the PSK, okay? That PSK with the MAC address of the client and the MAC address of the radio and a number that gets generated randomly by the client and a number that gets generated randomly by the AP. Those 5 elements are the ones that are going to be used to generate encryption keys. When you move from one AP to another AP, okay, then yes, you're going to have the same SSID, the same length of the SSID, the same password, so that hash is going to be the same, but the MAC address of your client may be different if you're using randomized MAC addresses. The MAC address of the new radio and the new AP is going to be different, so the equation changes, and then you have to generate new encryption keys once you move to another AP. Okay. Yes, 802.1x, it helps making that transition fast because there are different systems, different vendors do it differently, but once you go through that process initially and you generate keys, then the controller may pass those keys to other APs and say, hey, if Gabe comes here, these are his credentials. He's good. He already authenticated. His password is legit. His username is valid. He's in good standing. Let him through. Then once you move, that's what's called a fast transition. Once you move to another AP, you go there, and then you don't have to go through the whole process of authenticating and generating keys again. Once you go there, like, hey, I'm connected to this AP. I want to move to this AP now. And they're like, okay, yeah, I know you. I've heard about you. You're a good guy. Come in. And then it's faster. You can go like from 200, 300 milliseconds to 20 milliseconds, just moving from one AP to another AP. That's if you do 802.11k or 802.11v and R, usually those are together. Those are mechanisms that help clients roam faster. So MPSK, so PSK, when you have PSK, you type the password, and then it uses the SSID, the length of the SSID, and the password, and generates the hash, and then that hash, along with the MAC address of the client, the MAC address of the radio, and the anons, a number that is generated once by the AP, and the number that is generated once by the client, all of those things are used to generate encryption keys, so now all your traffic is encrypted. That's PSK. Since the password is the same for everybody, if I capture the four-way handshake, because it has those numbers that the supplicant generates once and the authenticator, the AP, generates once, if I have all this information from the four-way handshake, since I know what the password is, then I can decrypt the traffic for anybody if I capture all of these exchanges. Because I know your MAC address, I know your MAC address. If I capture your SNONs and the ANONs, then I have those four elements. What's missing? Well, the SSID, which I know, the length of the SSID, which I know, and then the only thing missing is the password. Well, the password, everybody got the password. The password is written on a card at the reception desk. The password is given to you in your receipt when you pay for your coffee. The password, see, then the password is going to be the same for everybody. At the district where I used to work, we used to Google, hey, what's the password for this school district? And he will come up and say, like, oh, the password for the Wi-Fi at this school district is, and he will tell you, like, oh, man, this is not secure. So PSK is not secure. Then they say, like, oh, if I have a company with 1,000 employees, and then Tom, did something bad and we fire him. Now he's got the password. So what are we going to do? If you have PSK, like, oh, man, we're going to have to change the password. Yeah, and we're going to have to tell the other 999 employees to change the password on their computers and their phones and stuff. So PSK, as you can see, is not good. So they say, like, how can we make this better? Also, if you are, this is very common at MDUs, multiple dwelling units, these apartment complexes that, have 200-300 units, and then they have Wi-Fi for everybody. Then they create something called, Ruckus calls it MPSK, multiple PSKs, in a way that when, let's say it's an apartment complex, and then I have 100 units. So I will create one SSID called complex, called housing. And then everybody has that SSID, but I will create a database in a way that apartment 1 is going to have a password, and apartment 2 is going to have a different password. Then every time that the people in apartment 1 comes, hey, I need access to a Wi-Fi, then I generate a password just for that apartment. So they can put that on their phones, their TVs, their computers. And the good thing is, if they are at the swimming pool, then they are connected and they are on a VLAN assigned to just that apartment. And then they can generate their encryption keys. And from their swimming pool, while they're watching their kids on the playground, they can send a print job to their apartment. And then it prints because it's the same network. And then when apartment 1 people leave, they say, like, okay, then we'll just create a new password for the new people that come in. And then now put this into context. You go to a company, and then if you have MPSK, multiple, and then everybody's got a name for that. Cisco calls it IPSK. Is it independent PSK or individual PSK? Any Cisco guys in here? IPSK, yeah, I think is what they call it. And then others call it not multiple PSK, but dynamic PSK, DPSK, okay? It's just PSK, but they have the way to interact with a database in a way that now if Tom leaves, like, fine, we'll just disable Tom's password. Then Tom cannot get in, but the other 999 people, they have their own passwords anyway. So with multiple PSKs, this is a system that can work, but it's still PSK. I can still get the four-way handshake, and since I don't have the password, I can get that hash, and there's sites online that you can put that hash and say like, hey, I'll pay you if you tell me what the password is. And then they say like, okay, what's the SSID? Well, the SSID is in the air. Here's the SSID. I just don't know what the password is. So like, okay, this SSID with this length, I don't know. Let's start. ABC123. Generate a hash. Like, is that hash the same as the hash we captured? No. So it's not ABC. So kitty cats 123, password 123, and then it starts guessing, doing a whole brute force attack. You can use dictionaries or non-dictionaries, or you can just pay $10 to one of these sites on the dark web, and they'll just get the password. Okay. Would IPSK be compatible with Meraki? I'm sure Meraki's got their own. Maybe they call it IPSK. I don't know what they call it, but identity PSK, is that what they call, huh? Okay, thanks, Ned. Identity PSK. Yeah, whatever they want to call it, it's just PSK, but then they have a back end that has a list of databases and users and or groups, and you can also control like how many times you can use that password. If you set it up in a way so you can only have 3 devices, then you have like, okay, I have 3 devices. If I have 4 devices, what do I do? Then you call them like, yeah, I cannot connect this device. Like, oh, yeah, you're going to have to pay extra for that. Now, if you ask Tom, he's going to say like, no, just put a Meraki, man. Just one MAC address, one IP, and then you put everything behind the Meraki. I mean, not Meraki, what am I thinking? MikroTik, get a MikroTik. Then you got to get the MikroTik, and then that's going to provide as many networks you want, and you're just nodding your way out. Okay, questions up to this point. All right, Tom says the difference between Cisco IPSK and Meraki IPSK is that Cisco needs ICE server, and Meraki does the magic in the cloud. Okay, perfect. Yeah, once you hear ICE server, that sounds complicated already. Okay, let me then show you, and let's analyze here. We have some 20 minutes. I know, sorry, we're going to go like 2 hours today, but this is important. Okay. Let me open Wireshark, and let me open a file. This file, oh, I can see now. Okay, let me open. Let me open. That's not here. Is in. Oh, crud. My Dropbox here. Hang on. Let me stop sharing for a second. My Dropbox account broke from my local thing, and now I have to go online to grab some files I need. Okay, Dropbox. There we go. This guy, let's download. Here we go. Let's download this guy. Let me actually download you first. Okay, and then we're gonna analyze this guy. Let me share again. Let me share my screen. Here again, put it on downloads. Okay, let me share my screen. Are you guys still here with me, or you guys got bored and left?
Yeah, we're here.
Still here.
All right. Devices on local network. Okay, so here's a packet capture I did on an association process from my phone. Yes, we'll have another session where we learn how to do this packet capture, but for now, just for the sake of time, and since we're talking association process, let's narrow this down. We have a total of, if you look down here, 3,797 packets that I captured. If I go to the end of the capture, it took about 18.4 seconds to capture those close to 4,000 packets. Where do we start? Well, if I look at my authentication frames. Here they are. The one we're going to look at is this one. It goes from an Apple device that the MAC address ends in D44C. And it's connected to a Ruckus wireless access point. So if I click on this authentication frame and clear the filter, now out of the 4,000 frames, it takes me right to that authentication frame. So it says right here, authentication. Well, before that authentication, there was a probe request. Of course, there was a beacon. There was a beacon that went from that guy announcing, let me just hide the interface. Let me make the time thing here smaller, the number of the frames smaller, destination address, source address, okay, what channel? It's on channel 36. Well, we don't need to see a channel right now. Info, the SSID, here we go. So there is a beacon. A beacon. See, that guy in this channel, that Ruckus wireless, ending in Echo 8 Foxtrot Charlie, that same guy, it sends a beacon. That's frame 1909. So let's write that down. 1909. Okay, that's 1,100 frames into the capture. That's when I'm going to look at that beacon right after the Apple device sends. Actually, here's one thing I can do. I start with this beacon, and if I right click on that frame and say set time reference, then I'm going to start counting time from there. So frame 1900, 9. The client sends a probe request. The Apple sends a probe request to the AP. Yes, if we look at the source and destination, here they are. The Apple sends it to the air. It broadcasts that, hey, I'm looking for a network called Guest Ruckus. Then the Ruckus AP like, hey, I'm offering the Guest Ruckus 5 network. You're looking for that network? I offer you that network. And this is what I can do. I can do this data rates. I'm on this regulatory domain. These are my HT capabilities. This is my robust security network information element. I have a PSK. I use CCNP. I will tell you everything about myself. See, it's like the beacon. See a beacon here? Very similar. Let me just actually collapse all this stuff. Here are the parameters. Here are the capabilities of that guy. And here what it's listing on the, oh, watch that. If I click this guy and that guy, this guy, notice that the information elements are almost the same. Yes, we could spend more time just looking at what's the same, what's different, but it's about the same thing. Then the client then gets the beacon, the client sends a probe request, gets a probe response. We're just going through what we just covered in class today, analyzing a real association of a client. Then right after this guy sends the probe request, probe response, there are other frames, other devices announcing beacons here, comes code there. There's a Ruckus announcing otra vez sending more beacons, and then other stuff happening, more stuff is happening. And then finally here in frame 1173, the client sends that authentication frame to the AP. This is unicast. See, it has the source, the transmitter is Apple, the D44C, destination, the receiver is that Ruckus AP, and then this is a small, see, this is an 84 bytes frame, and it's like, hey, this is an open system authentication. See, open system authentication, sequence 1, I'm basically sending you, say, I like you, and then the AP immediately after, like a tenth of a second, a tenth of a thousandth of a second later, it replies, see, transmitter, Ruckus, destination, Apple, and then it says, okay, you are successfully authenticated. That's it. Now what else? Now the client sends the association request frame, okay? The client sends the association request frame to the AP, to the Ruckus wireless AP. Source, destination, and then in here, This is that frame, the association request frame is that frame that we can capture for any device, a barcode scanner, a tablet, a Chromebook, a laptop, a phone, whatever it is that is connecting to your network. If you capture that, it will tell you, I'm looking for this SSID. Here are the data rates that I can do. Here are the power constraints I have. I can do maximum at my best, full battery, full power. I can go 21 dBms. That's it. And then I can do these channels, channel 36, range of 4, so 36, 40, 44, and 48. If I look at Adrian Granato's tool right here, if I look, it says channel 36, 44, and 48. I can do Uni 1. And then I can do channel 52, range of 4. So I can do channel 52, 56, 60, 64. Basically, this device can do Uni 2 as well. And then channel 100, range of 12. Then if you start counting from 100, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. It gets all the way here to channel 144. It can do Uni 2 extended. It can also do channel 149, range of 4. So 149, 153, 157, 161. And it can also do channel 165. So basically, this phone is telling the AP, hey, man, I can do every channel except, of course, 173 and 169 and those in Uni 4. I can do all of those channels up to 165. So if I have an access point right here in channel 173, now in the US, we have Uni 4, which gives us channel 169, 173, and 177 in 5 gig. This phone would not be able to connect if I have an access point here in channel 173. Does this make sense? Because this happened to me. At a school, I had a group of computers couldn't connect to DFS channels. I captured the association frame, and they could only do Uni 1 and Uni 3. They didn't do anything between 52 and 144. So that device couldn't do it. It's like if you have an AM radio, you will never be able to hear an FM radio station. It's that simple. It was a capability. So this association request frame is extremely important. It also has how many spatial streams the client can do. Let's see if we can find that here. Yes, we can. We'll have to dig here a little bit. Let me see if I collapse all this stuff and then just open this and open that. Very high throughput capabilities. If I look at these MCS sets and I look at this map, the device says I can do 1 spatial streams, MCS 0 through 9. I can do 2 spatial streams, MCS 0 through 9. 3 spatial streams, like, no, I cannot do 3 spatial streams. So this is a 2x2, a phone with 2 spatial streams. So all the capabilities of the client are here. What channels it can do, power levels, spatial streams, regulatory domains, all that stuff. The access point, Ruckus Wireless, will send the association response like, oh, yeah, so you can do this. Then I know I have all this information. So when I talk to you, I know how to talk to you. And then I will also assign to you an association identifier. You are AID01. Okay. Then, since I have a PSK in this network, what comes next? Well, the 4-way handshake. See? Key 1, key 2, key 3, key 4. So the first key is the Ruckus Wireless sends the client kind of like a challenge, like, hey, hold there, Buster, I have a password. And then it generates, just open this stuff in here. It generates that A nonce, there's a number generated once for this session. And then that is the access point sending that challenge. And then the client responds with the second one, like, yeah, I got a password too. And it encrypts all that stuff and it's sending that number. And then we'll have another session on just PSK. Then if the passwords match, then the client will receive from the Ruckus AP the third key with more. Let me just click in this guy in here. Hang on. Right there. With more keys to be placed, the KEG, the KCK, and all the additional information for key generation for encryption of unicast, for encryption of multicast. There are group keys and just PTKs for the client and the radio to encrypt their own data. And then there is some group keys that the AP will use for multicast and broadcast traffic. So it is encrypted with all the people in that group. And then the last one of the four-way handshake is the client basically saying, like, okay, I got the keys, I set the keys, we're good. Now, from now on, all the data is going to be encrypted. There's going to be a field that says this frame is not protected. Stay up, see, data is not protected. All of this stuff prior, that stuff is not encrypted. But then after it goes through the four-way handshake, notice that this data is protected, data not protected, data is protected. Then all of the exchanges that are protected, now they're using encryption keys. Okay, that's the four-way handshake up to this point. What comes next? Well, the client needs an IP address. So we are at frame 1988. Why do I leave this here? Just to show you that, look, if I can make a search for DHCP, here are the DHCP addresses, the whole DORA process. But let me just clear this. We were here at frame, see a four-way handshake, 1988. If I keep coming down, let's see, where is my DHCP discover? See right there? This is the client. Now, how do I know it's the client? Let me show you. If I break this down, the Apple device, D44C, sends a broadcast making a DHCP discovery. Basically saying like, oh, look at me, my IP address is 00. I don't have an IP address. I'm discovering, I'm trying to find an IP address. Now, this is not Wi-Fi. This is just the same process that any device you connect to a network goes through to get an IP address. It sends a DHCP discover. This is the DORA process, not the DORA, the Explorer, DORA, discover, offer, request, acknowledgement. So the client is looking for an IP address. Say, I don't have one. Here's my MAC address. I'm looking for one. Then that's the DHCP discover. And then in here comes a DHCP offer. Comes from where? Well, if I come back here, who is the source? Well, unified a local domain. I have a unified device that provides the IP addresses. That's my DHCP server. That's the guy that responds. And through the Ruckus Wireless, that's the radio transmitting that, sending to the Apple D44C, it sends a DHCP. Where did it go? Where did it go? Well, right here, the DHCP offer. And then it said like, hey, you know, I offer you the IP address of 165, 192.168. That's the offer, okay? And then not only that, it also tells me what the lease time is. It gives me information about the router, and it's just DHCP. Any DHCP options, if you want to add the controller in here, whatever specifics you have, it's all in the DHCP offer. Then more frames go by, it's your turn, the Cisco sends this, the Ruckus sends that, this Vanta, the computers and this, and then there's a lot of stuff happening in the air. Where is my DHCP request? Where's the request? Come on, where's the request? Did I went past it? Yeah, right here, there's gonna be a DHCP request. The DHCP request, if I look at the source, is the Apple device sending a broadcast and basically saying like, okay, you offer me an address, I am requesting the 165 address you offered me, okay? And then now the server the DHCP server sends an ACK. Like, okay, Mr. 165, from now on, that is your client IP address. Now the DHCP server has the MAC address of the client and the IP address of the client, and that's how it's going to switch and route throughout the network, depending on where you are. If it's a local DHCP server or remote, then it's going to have all of the information along with all of the information of different options that you have, DNS, if you have additional ones, or if you have DHCP options for your controllers, for your access points, all of that is there. Now the client finally has an IP address and can do business as usual. Phone calls, Zoom meetings, web meetings, can do WebEx, Cisco WebEx, can do whatever, because now it has an IP address and now the client is ready to go. So I started at frame 1909. I am at frame 2493. Somebody there, do the math, get a calculator out. What is 2493 minus 1909? Anybody there was left alone?
Sorry, not enough coffee.
No, what's the last number?
2493 minus
584.
584 frames later, I finally have an IP address. So that's the process since the client receives the beacon, pro request, response, authentication request, response, association request, association response, and then it goes through the four-way handshake, and then it sends a DHCP discover, and then gets an offer, and then it sends a request, and it gets an ACK. Now I have an IP address, I'm ready to go. 584 frames later, and time-wise, since I set a reference, it took about 1.9 seconds. Wow, that's pretty good, huh? 1.9 seconds. Well, that's 1,900 milliseconds. Is that good? You networking, guys? What's the ideal time for you to get an IP address and be on the go? I mean, as close to zero as possible, right?
Yeah.
But what's acceptable? What's like if you're on a voice call and you are moving from one IP to another?
Yeah, but it doesn't DHCP again when you're moving an AP to another.
Yeah.
Depending what type of routing you have, or if you're doing layer 3 roaming. But in this case, you just connect to a network, and now let's say you come from cellular to Wi-Fi, and then you have to go through this whole process to jump into a network. So what's the ideal time, Gabe?
For voice, it's 20 milliseconds.
20 milliseconds. Okay. So we're talking about 1,900 milliseconds. That's a long time. If you are roaming and you don't have any fast transition mechanisms, and then, yes, maybe the DHCP server is the problem, or maybe it was the client, or maybe it is the air is too busy with all these beacon, and these other things happen in the air. Whatever it is, if it takes too long, maybe by the time you already went through the whole association process and the four-way handshake to verify your password, your credential, and then you get an IP address, and then it takes too long, maybe by the time you try to talk, you already dropped the connection. The session ended, the Citrix server timed out, the VPN session disconnected you, and then now it's when you have to retype your password and your credentials to get into other stuff. So this is just to show what is happening in the air every time a device is trying to connect to a network. If you don't have fast transition mechanism, then when you go to the next AP and you're moving and you're roaming, you have to disconnect and go through the whole process again. Probe request, probe response, authentication request, association request, association response, and then, whoa, I got a password, PSK. Then what is the password? Then you go through a four-way handshake, and then you generate all those keys. Yes, the IP address maybe is like, oh, I'm just going to keep the one I have because it's good. But then that whole process may be long enough for you to notice a disconnection. Kind of like when I moved from one AP to another AP here, you guys lost me. And I could have been saying like, yeah, and this is the winning number. And then by the time I got back, you like, man, I lost you there like for 5 seconds. All right. That explains it. Okay, let me review the chat in here. DHCP was the top issue in the last network I worked in. Yeah. Tom, yes, under 150 milliseconds. Yeah. When we talk about 1,900 milliseconds to get a miserable IP address, yeah, something's wrong. Then that's when we have to start digging. What took so long? And then you can start looking at the delta time and identify how long it took the process. And you can filter more. Now, why am I seeing this information? If I do DHCP, I can see the discover and I can see that, and I can see that from one side to the other, even though it says that this data is protected. Well, it's because I added the decryption keys to Wireshark. Okay. Let me make sure I don't have any decryption keys I shouldn't show. Hey, try to keep this secure. Not that I don't trust you. I trust you. I just don't trust the internet. Here, let me go over. Look at protocols. And this guy and decryption keys. Let me get my eyes on. Oh, beautiful. Yes, this will work. Okay, let me share my screen again.
Yeah,
If I
open
right,
to
okay, now in your screen, okay, if I right click here on any of these packets and I go to protocol preferences and IEEE 802.11 LAN and decryption keys, I'm going to leave this in the screen here for a second. If you want to take a screenshot and kind of like see where that's done, then if I hit decryption keys, I have added the decryption key for this network. It's just my phone number and so that's the password. That's how you put it. Password and then SSID. So if you want to find the decryption keys or just create the ones for you, go ahead. For your network, this is the format. You add a decryption key, you click on the plus sign, and then where it says type, it is WPA password, not PSK, password. Okay, password. And then the format in here is going to be you first put the password and then colon, the two dots, and then the name of the network, the SSID. With this, now Wireshark creates the hash, and then it has the MAC address of the radio sending the client, the MAC address of the radio of the AP. It has the A nans and the S nans, those numbers that were creating the four-way handshake, and now it knows the decryption keys. That's why I see this. Watch this, frame 212. Let me write them down here real quick. Frame 212. 1212. Oh, 2112. 2112. 24. 2489. And 2493. All right. Here's another place where you can go to the decryption keys. If you go to Wireshark preferences, on Windows, I think it's edit and preferences. And then you go to protocols and scroll down to IEEE 802.11. IEEE 802.11. And then there is decryption keys. It's the same as right click on a frame and then go do. And then here it is. So I could delete it, but then I'm going to have to type it again. I'm just going to change one character. I'm going to delete the 5. Eyes on the screen. Once I apply this and apply that, all of the encrypted data is gone. If I go to frame 2112, if I go to frame 2112, remember that it had like the DHCP discover and you could see all of the information. See, it goes from the Apple to FFFFF. And then once you go down below, you don't see the DHCP discover and all of the contents of it. You just see hashed data, encrypted data. And if you come over here, it says data is protected. This is why having a PSK, I mean, it helps. It can be cracked, but not as easy. And the average Joe is not going to know. And yes, if you have tunnels, you open a session with your bank, that's going to be on an HTTPS and using secured tunnels, then that's still going to be encrypted. But there's a lot of information that can be learned when you have those encryption keys. What was the other frame? 2124. So if I go to 2124, there was the Cisco Meraki sending me the DHCP offer. If I go down, there's no offer. I cannot see anything. I don't know what IP address I got. Remember, Wi-Fi only operates in layer 1 and layer 2. That's it. And then the other frame was 2484. 2484. Right here. That's not it. Oh, 2489. 2489 from the Apple broadcast. That was the HCP, that was the DHCP request, but I don't see any of that data. It's all encrypted because I don't have the decryption keys. If I go over, see, and now if I make a search for DHCP, nothing. But if I go and add, let me just right click, protocol, wireless LAN, decryption keys, and then I add the SSID, it was 5. And then now I give Wireshark the information. Now it decrypts the data that was encrypted with those encryption keys. Questions or comments up to this point?
I'm okay.
All right. Simple enough. With this, my friends, we get to the end of session 358 of Tesos and Wi-Fi. Today, this is part of the class, the Wireless LAN Professionals Wi-Fi Design class. We will be covering everything that has to do with how Wi-Fi works, encryptions, and all that stuff later, but today we cover the association process. How is it that a device will connect to a Wi-Fi network? What's the process? We have AP sending beacons announcing the capabilities of the network. Beacons go out 10 times per second per radio per SSID. Did I mention that before? Yeah, I mentioned it many times because the next time you hear somebody say like, hey, Sebastian, come and put another network here. Like, why? In your mind, you're going to be like, more beacon, 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 beacon. I don't want more networks. I want less network. How do we simplify this and reduce the amount of airtime that is being wasted in overhead? Well, not completely wasted, but unnecessarily used. You know, just reduce it, simplify it. Then the clients can also discover networks by sending probe requests and receiving probe responses. And then they send an authentication frame, receive an authentication frame back, and then send an association request frame and receive an association request frame back. And if you have PSKs or DA1X or different methods, then you're going to go through that. And then you will get the association identifier, and then you get the authentication taken care of, and then you get an IP address. We went through that process. That's what we reviewed today. So with that, my friends, today is Sunday, July 26th. Thank you very much for spending time with me today. Free love for everybody and free Wi-Fi training for everyone. You have a good rest of the weekend. Until next session. Remember, if you want to come and join us live, then I posted the link for the form that you just fill in. It's just a matter of sending a form. Where did it go? Where did it go? A form with your name and email. I'll send you the invites for the Zoom session. And then I don't know where the form went. Here you go. That's the form. Two things. Your data is not shared. I don't sell data to anybody. I don't borrow data. I don't share your names or emails. I know people have asked me like, hey, can I get a name, a list of names on emails of people that came to your class? No, sorry. We don't do that here. I'll buy from you. I don't care. I don't need the money. This is your data. I'm not going to share it. It's just for us. Okay. So that I can let you know when the next session is, which we don't know when it's going to be. Maybe tomorrow. We'll do another one tomorrow. I'll see how as time permits. I'll see you next session. Have a good one. Goodbye.
All right. Thank you very much. Thanks, everyone. Bye-bye.
Thank you, Ferney.
Take care.
Thank you.
Thank you.
Beacon, 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 beacon. That's right.